We all know about the solar system, but do we spend time to actually pay attention to some of the images, some knowledge that the astronomers and NASA can give us about different planets, celestial bodies within our solar system? So let's see what we're going to learn today. I'm going to bring some pictures, also pictures that we have gathered from probes, also from the Hubble telescope and the James Webb telescope. So enjoy on this. Hopefully you will learn something new. When you're thinking of the solar system, we have the sun here, which is at the center of our solar system. It is the largest source of gravity in our solar system, and this is what is keeping all these planets in orbit around it. Now, between Mars and Jupiter, we have the asteroid belt. We're going to talk about that as well. And beyond Neptune, we also have the Kuiper belt, that we have also dwarf planets there. So let's see if we can learn something new today. Our first planet will be Mercury. So this is a colored picture of Mercury to tell us some of the differences in geochemistry. Let's see if I can make it bigger for you. There you go. So here, the colors to show us a bit what's happening on the surface. Mercury is the closest planet to the sun. Interestingly enough, it is the hottest planet because there's no atmosphere. So during the daytime, it's very hot. During the nighttime, it's very cold. And some people will say, well, how come there is no atmosphere at the Mercury? Mercury has no atmosphere because the gravity is not big enough to hold together an atmosphere. So the solar wind has been shining over Mercury for billions of years and has pushed away any particles that could have made the atmosphere here. So when we have asteroids, and let's see if I can have a good sample here. So here's an example. So we have an asteroid that hit the ground without the atmosphere to keep the ejecta in with small gravity. So what happened here, we have a crater that is about 23 kilometers, and then you have the ring here of the crater. But look at how far some of the ejecta is going, because it's going up with small gravity. It's taking time to come back, and there's no atmosphere to slow the particles away. So this is quite an amazing crater right there. So if we look, so this one here, it's called, let's see how they called this one. So it's called the Radon-Salé crater. Very interesting on this one. Another picture, so we talked about the eclipse not too long ago. So here's a picture of Mercury. There you go. So here we have a sun. Could we have an eclipse from Mercury? Mercury is this little dot right here. So if I go down a little bit, this is a composite of Mercury orbiting around the sun. It's much closer to the sun than us, but you can see the path of the orbit. This is one of my favorite pictures about Mercury. It's amazing how, even though Mercury is a huge planet, it is looking quite small when you look at this version. Very good. From Mercury, we will be going to Venus. Venus is a sister planet for Earth. Venus is interesting because if you look at how the surface is, we don't see many craters from asteroid impact. And one of the reasons for that is that there is an atmosphere around Venus. So the atmosphere is creating disintegration of many of the materials coming from space before it lands on the surface. And something that is interesting is the surface is still moving and changing. There's a lot of volcanism on the surface. So that means that as there's a change, there's new lava flow. Consequence, if there were any crater, they've been covered and it's tricky. So they mentioned that the surface of Venus doesn't have, or doesn't appear to have, as many large thick structure like the Canadian Shield, for example, where we have a continent. It seems to be a bit softer overall, especially in the middle part right here. So let's see what else we have. I have this picture here that is interesting. So we have the sun, and you can see here the size of Venus. Venus is bigger than Mercury and closer to us. And here's an amazing composite of pictures of Venus crossing here between the sun and us. And here you could see some of the activity here on the sun. It's amazing. So let's see what else we have. So I'm going to put the links when I edit the video. But here you could see that if you have volcanoes, like you would have on Earth, volcanoes will be erupting and adding lava on the surface, and therefore changing how it looks, changing how the surface is. That's why we don't see as many craters. This could be a reason why the atmosphere has so much sulfur and sulfuric acid, nitric acid, and a few other acids. It's not a great place to be. We haven't been able to send many probes on the surface because every time they get close to the surface, the acidity of the atmosphere is just burning the components of whatever we sent on to Venus, causing a lot of difficulties with respect to recording any data. But we're trying to send a few people here and there, and it happens as we can. So this is Venus, and let's see if we can go to our third planet, which is, you're right, we have our planet Earth. So here you could see a picture that's from 1972. You can see our Earth, which is a beautiful sphere. We have several areas where we have continents, where we have solid crust over the mantle. We have a lot of water. This is the key difference between Earth and any of the planets in our solar system. We have water in its three states. So we have vapor in the atmosphere, we have water in ocean, lakes, and river, and we also have water as form of ice in the cryosphere on the northern part here of the planet. And here you could see the southernmost part of Earth here in Antarctica. Quite amazing planet. So let's see if we can look at a few other pictures. If you look at this one, another great way. So when we send probe into space to study other planets or the sun, we also put a variety of cameras to take data. So here we have a probe that is showing us Earth, and we have here the moon. We can see that the sun is coming, sends light from the right, and is lighting this portion here of the Earth and this portion here of the moon. It's quite amazing how, even though we think we are very important, we are very tiny on our Earth, and Earth is tiny in our solar system. It's quite interesting to think of the reference point. Very good. Now I'm going to show, another point interesting. So knowing that the Earth is rotating on itself, what happens is that during the night, we have nighttime, but humans, with their brain and the way to improve our quality of life, you can see in Europe, Amsterdam, Paris, London, where you can see the lights during the night, so that humans have learned to adapt to the rotation of the Earth and day and night. I'm going to show you one of my favorite video in astronomy, and this one here, I'm going to just start from the beginning, is a video that is showing the moon in transit between us from the probe taking the video and Earth. So here what you can see the sun that is in transit in front of the Earth here. So here it is showing us the hidden face of the moon. So here on this part here, we have, so on the other side, humans will be able to see the new moon. There's no light at all. And here we have the light on that hidden side of the moon. Often people have a conspiracy theory to say what is happening on the dark side. It's not always in the dark side. It's dark because we don't see what is happening there. And then you can see the moon in transit as it goes along. Now, we don't send very many pieces of equipment on the moon surface, on the far side of the moon. And the reason for that, it's hard for communication. So I know that China has sent many probes and many pieces of equipment to land on the moon. And what they do is that they have an orbiting satellite that is sending information from the equipment they have on the far side, and then they use the satellite as a relay to go back to Earth. So this is amazing. So you can see how this can be one of my favorite video. So here we have from Earth, so we have a telescope aiming at the sun, and these here, they're not the sunspots. It's actually the space station that is sailing across the sun. So this is from Earth Observatory associated with NASA. You could see here the space station traveling. So here it's interesting because I've mentioned how Mercury and Venus was going between us and the sun, and now here we have a man-made object or human-made object crossing in the sky. It's always nice to see. Perfect. So let's see. Our fourth planet now is Mars. Mars is the fourth planet, and humans are interested to go to Mars. Now, they cannot go to Mercury, it's too hot. The environment is too harsh. They cannot go on Venus because the environment is too harsh. So, Mars is the second planet that humans can go and would have somewhat any success. And the reason for that is that there's a thin atmosphere around Mars, a thin atmosphere where we've got nitrogen and methane and a few other gases, which could be used as resources for humans to go. Now, we have here that Mars is about 53% the size of Earth. So I don't know if you can see, it's right there. So that means that we have the gravity is less, but the atmosphere makes it that it's interesting. I had some good pictures. So here are examples of rovers that we have sent on Mars. We have a name for this one. So this is the Curiosity Mars rover. And we send a rover so we can study the surface of the planet. We always want to see, so we have sedimentary rocks here. So were they deposited by wind or were they deposited by water flow? This is always what we want to know. So far, the rovers are going there to collect data, but they have very minimal capabilities to send us data back. However, Curiosity is taking samples and dropping samples along its path. And the whole idea here is to go and collect those samples and bring them back to Earth. That's an interesting project that will come up in the next decade or so. I have another picture for it. So here's another picture. It's very desolate. There's no water. There's no life. What is interesting is that reddish color. And some people say, well, how come it's red? And the main reason I will say, okay, so if you think of iron and you leave an iron bench outside with the rain and the atmosphere, that bench will eventually rust. So we have iron and oxygen from the atmosphere coming together to create a new compound that is orange. And this is what we call rust. So on Mars, we suspect there was a lot of oxygen in the atmosphere. What happened though is over the millions of years, the billions of years, what would have happened is that the oxygen from the atmosphere would have joined with other atoms and minerals on the surface, creating new compounds, but extracting the oxygen from the atmosphere. So there's a lot of oxygen on Mars. The issue, though, is that it's all locked in the minerals. And the question is, do we have the equipment? Do we have the resources so that we can extract the oxygen that humans would need to be able to live? So Mars, amazing planet to go and visit. Now, beyond Mars, we have what we call the asteroid belt. The asteroid belt is here, if you can see. So we have the sun in the middle. We have the four main telluric planets. And then we have this materials here between Mars and Jupiter. So the asteroid belt here, we could say that it could have been a protoplanet that somehow never were able to aggregate together. So it could be because we have Jupiter here, so the gravity of Jupiter as it was orbiting around the sun. We had Mars here, so every time something wanted to get together to create a protoplanet, it would just destroy it, and eventually it just litter all this part here around the sun. Now, on this asteroid belt, we have mostly dust particles, we have rocky asteroids, we have metallic asteroids, and we have asteroids that are a mix of metal and rocks. Now, within this here, we have two dwarf planets that we can consider. So we don't have any planets here, but we have dwarf planets. They're dwarf planets because they're much smaller. They're not big enough to be considered a planet. So the first one is Ceres. So Ceres here is about 700 kilometers, I think. Oh, I forgot. Let's see if we can look at it together. Let's see. Is it this one here? No. So diameter of, let's see if I can see, of Ceres. So we have a diameter of about 1,000 kilometers. Now, 1,000 kilometers is enough to create enough gravity to create a spherical dwarf planet. And the reason for that is as this celestial body was attacked and bombarded with different asteroids and other celestial bodies, there'll be a crash, a crater, and there'll be an ejecta, and it will fall down uh, around the crater. So over the billions of years, what happened is that if this, imagine this to be a cube, over the billion of years, it will just be rounded and rounded to be able to get about a thousand kilometer dwarf planet, which is interesting. Now we also have, so this is an interesting way to go and visit because it's stable. But asteroids for us humans, we're more about, we want to know more about metallic asteroids, because if you could approach a metallic asteroids and be able to mine some of the metals, it could be so economically interesting for us. The other large dwarf planet is Vesta. Now, Vesta is about, if I remember well, let's see if I can go back here. It is about 500 kilometers in diameter. So here we have a dwarf planet that is half the size of Ceres. And if you notice, it's not a sphere. And the reason for that, it's not big enough to have a large enough um, gravity so that when you have asteroids and objects hitting it, to be able to route it up over the years. Now, you've noticed that there's appear to be some structure into it. So the big question, and I do not know, if you know, you can tell us. We have the structure here of maybe a protoplanet, something that was trying to get together and was finally broken up. So here you could see there's a structure, and it's interesting to see. It is not a sphere because it's not big enough to have gravity to create a round spherical object. So once we go from the asteroid belt, let's go back to our drawing here. So we've done here the first 4 planets. We have the asteroid belt right here. We are going into Jupiter. So Jupiter is the biggest planet of our solar system. So let's see what we can learn. Oops, there we go. Oops, I think this is not the one. There we go. So Jupiter is the largest planet. It is a gaseous, it's a gas planet here. Let's see, there must be, I forget the English word. That's interesting. So we have here a Jupiter. Its surface is a big atmosphere, and somewhere we have a large, there we go. So we have the large red eye here. It is an ongoing storm that has been going on for as long as humans have watched Jupiter. I know that it's moving over the last decades. It seems to have decreased in size on its surface. So it is quite an active planet. Now, let's see if we can look at some interesting points. So here we have Hubble, the first space telescope, and we have here, look at the details that we had here. Earth is about the size of this eye right here, plus or minus several hundred kilometers. So Earth is quite small compared to Jupiter, and you could see here how the wind are moving on this planet. Now on Earth here, with our thin atmosphere, we have large trade winds at the equator. So what happened here, we have large wind, and there's less and less wind as they go further towards the South Pole and the North Pole. Now, a few years back, I think it's a year and a half ago in 2023, 2022, we were able to get a picture from James Webb Telescope. So here we took away the reddish color. So this is the what we would see. So they're more natural color. We can see here the storm of the eye, but we can also see how the atmosphere is changing on north and south. And here we can see we have northern lights and southern lights here. So these lights here are caused by the magnetic field of the planet. And it's interesting to see that the more we research planets, the more we can actually learn. We've seen Jupiter pictures for a long time, but the more we have amazing technology, the more we can actually see some structure and see some phenomena that are close to what's happening on Earth. It's always exciting. Jupiter has four large moons. So the four large moons are right here. Let's see if I can. So we have Ganymede, and Ganymede is larger than our moon. We have Callisto. We have Io. Io here, what is interesting, it's a volcanic moon. So we have volcanoes of that on that moon. So we have here mantle where we have magma playing. We also have Europa. If I click here, can I have more a bigger picture? There you go. That's beautiful. So we have Europa. Europa is an ice moon. So it's all covered in ice. Now, when we talk about ice, it doesn't mean it's ice created from water. There'll be some water, but you'll have also nitrogen, carbon dioxide. You have several gas that are in solid form because of the temperature. So scientists are thinking in part of the theory that we have liquid water at a certain depth, because at a certain depth we have the pressure of the ice here, and it's possible that there's some liquid water, and that's what would create movement of this ice layer, creating all these cracks on the surface. So I've heard many times that humans want to go there. They want to send a probe right here. They want to have a probe that heats up so they can go under the surface to see if there's any water and possibly see if there's any life. The difficulties with this one is, first of all, it's very far from Earth. Therefore, solar panels will not work. So you need a source of energy like nuclear battery. Would it be safe for the planet? We want to make sure that it's sterilized, because if we were to go in a place where there's water, saline water or otherwise, we don't want to contaminate the planet, or not the planet, but the moon here. That's something to look into. Now, when we look at the size of these moons, here's an example. So we have Earth right here with our moon. So when we think of the four large moons of Jupiter, they're very close to the size of our moon. Now, they can be bigger than our moon, and the reason is that Jupiter is much larger as well. So these could have been dwarf planets that were going in our solar system and got caught in the gravitational field of Jupiter. So lots of action. This one here, I've seen pictures where they have plumes here of volcanoes and some particles going to space. I just couldn't find the picture today. If I find it, I'll make a video on that. So let's see. So from Jupiter, we go to the second gas giant, which is Saturn. So here is a typical picture of what we see of Saturn here. So we have the planet and we have the rings all around it. So this is the second largest planet. Let's see if I can find good pictures for it. Oh, I like this one. So here's an example. So here around the planet, we have rings of particles and dust, ice, a whole bunch of different little blocks. And this is the one that we can see it the most precise. So this is from NASA indeed. I'll put the picture here in the comments below if you want to have a look. Sometimes I lost myself in just looking at pictures of planets. Always interesting. So here we have the rings, and you can see how the details are for these. If we look at some other examples, we have, let's see, this one is a great one as well. So here you can see the full disk. So you could see that on Saturn, you also have some differences in the atmosphere here, in the gas that is surrounding Saturn. Same way as Jupiter, it's made of hydrogen, helium, and it's a gas at the surface. As it gets closer to the center, the pressure is high enough, it's probably liquid and solid hydrogen at that point. Perfect. If we go, so here's another example with colors. So here's humans add colors to make it so that they can see the difference. We can see here, like Jupiter, we have lines with different winds, trade winds on Saturn. We also see in places little moons that are available. So let's see if we can. So this is what we've seen often in textbooks. Now I'm going to show a few other pictures that are quite amazing. So this one is a picture from Hubble telescope. And you could see here that Saturn also has a magnetic field, and you could see here the northern lights at the top here of Saturn, and we can see the rings right here. Now the rings are changing. I was reading a paper, and they expect that in 1 to 200 million years from now, all these particles, or many of them, possibly most, will be all going into and land on Saturn. So we can see the ring here, but in 100 million years from now, we're going to see a lot less. And Saturn is a planet with rings that you can see with a telescope. I remember maybe 20 years ago, I was in Mississauga, and an amateur astronomer had a 30-centimeter telescope, and I was able to see a little white dot and the ring around Saturn. So that's a planet you can see if you have a good telescope. So that's exciting. Another picture that is always amazing. So we have the James Webb telescope that brought us other amazing pictures. So you can see here the rings. Actually, the one I just showed you, this one here, it says Hubble telescope. Interesting. And this one here, it says, so that's the Hubble as well. Is there something from, so I thought I had a picture for the James Webb. So they show this one here, and it shows that there's a giant Saturnian storm that was observed in mid-infrared. So this is, so here, a much more detail, keeping in mind that the James Webb telescope is aiming at the far distance, for galaxy and beyond our galaxy. But if Saturn is passing by, it can look at some ideas. So here it says, the warm gases powering the storm make it glow brightly compared to the rest of the planet. So here it's color-coded. It's very interesting. So this is a picture from James Webb telescope. Now, what is interesting with Saturn, it has a moon called Titan. And interestingly enough, Titan has an atmosphere. And I remember last year, so here it says November 4th, 2022. So it's a year and a half ago. I remember seeing this picture here of the atmosphere of Titan. And I remember that they were showing specific pattern with time lapse. So two pictures with time in between. And we had this cloud B that was here at some point that had moved. And so we had cloud A and cloud B, and you could actually see there was movement. So this is a color that was made by a human. It doesn't say that there's any vegetation. It just shows that it is an active, it's quite active on that moon. And if you look here, so we have here Earth, we have our moon. So here Titan is almost twice the diameter of our moon. So it's much bigger gravity, and that's how we would be able to get an atmosphere there. So there must be some heat source to make sure that the gas will not turn into a solid. So here, lots of things going on Titan. It would be amazing to go. Then again, the distance to get there is always the biggest issue. So here's the picture here showing Titan. It's quite exciting for astronomers. From Saturn, we are going to Uranus. So Uranus here is the first ice giant, we could say. It's much further, much colder. We often refer to it as a bluish planet like this. Now, we were able to get from James Webb telescope, look at this amazing picture. I'm going to go up so you could see where it is from. So here it's from the Webb Space Telescope. So here, when you look at this one, so you could see, I'm going to break this down. You could see a few things. So you could see structure in the atmosphere. You notice that the ring seems to be going sideways like this, because Uranus is the only planet that doesn't have an axis of rotation, more or less vertical. It has an axis of rotation that is 90 degrees at an angle. So that means it's the same thing as if it was rolling around the sun. But amazingly, James Webb was able to take these pictures here of these amazing rings that was very hard for regular telescope to take picture of. So this is quite amazing, and here you can see different clouds. So you have astronomers studying what is happening on on Uranus. The next ice giant is Neptune. Neptune is interesting. We also have, so look at these pictures here. So this is also from James Webb. Neptune also has these rings. Do I have it closer? There you go. You also have from Neptune, you could see in the atmosphere, lots of things going on. The reason why Uranus and Neptune appears blue is that it seems that we have, on top of hydrogen and helium, a little bit of methane possibly. So what happened is that the red wavelength of light is being absorbed, and that's why we tend to have less red coming from them. And here around this one here, you could see these little moons that are going around Neptune here. This picture is always interesting for me. So here we have Triton, which is much closer to us in these pictures, and it shows that it's much brighter. And here, if you see the star shape here, that's a key example of pictures from the James Webb Telescope. We have mirrors that is made of multiple mirrors that are all in hexagonal shape. So when we get pictures, we get something like this. So computers are cleaning up usually the picture. So that's quite exciting. Perfect. So from here, we have the Kuiper Belt. So there we go. So let's see if I can go back to my first one. So here we have my the picture I had for the solar system. So here we have just looked at Neptune. We are going beyond Neptune. So here beyond Neptune, we have the dwarf planet called Pluto with its moon Charon. So we have many celestial objects beyond Neptune. So let's see if we can have a quick look. So when you think of beyond Pluto, we have what we call the Kuiper Belt. The Kuiper Belt, there you go, very similar to the asteroid belt, is much further. But on top of that, above the dust and rocky asteroids, we are, from what I know, a lot of our comets comes from the Kuiper Belt. It's much further, it's much colder, and therefore there's a lot more material made of ice. And you can see here, Pluto doesn't follow the plane of orbit here around the sun. So here, because of its size, orbit a bit different, it's not a planet. So here the Kuiper Belt, it's a variety of materials that is all lined up here. But we have been learning more and more about it with the bigger and better telescopes that are space telescopes. We've been able to see amazing things. So for example, we have Earth here. We have what we call trans-Neptunian objects. So there's quite a few of them. So these are the biggest. So there's Eris here with its moon. There's Pluto indeed with its moon, with two little materials that are on either side. We have Makemake, Haumea. This is one of the first one I learned of, Sedna, and so on. So these are the biggest one. It is possible that we might find one that is so big enough that we could consider a planet. But at this time, we haven't seen one of those, and I don't think knowing how the astronomical culture is will ever add a planet to our solar system. But we could add an object that can be bigger than it is in the Kuiper Belt, in the Kuiper Belt. There you go. Very nice. So here, if you look at Pluto, we have there was a mission called New Horizon, and this is one of the best picture we got from Pluto. We sent a probe. The main reason why we sent it was to go and take pictures of Pluto. Now, New Horizon has gone past Pluto and is sending us information about those trans-Neptunian objects. So we are receiving data. I haven't seen many pictures or live pictures of recent pictures from New Horizon. Maybe that's something I'll have to look into. If you're interested, tell me, and I'll see if I can make a video from data coming from New Horizon. Very nice, and good. So we've talked a lot about planets. We've talked a lot about the belt. We've talked about dwarf planets. There's a lot more objects around us. So many of them, they're called asteroids. Asteroids are quite big. They're made of rocks and metal or a mix of both. They are comets. Comets are made of ice and dust. So when they come close to the sun, they tend to melt. Lots of great things to do about that. If you're interested, I'd be more than happy to make a video with them. And we have meteors. Meteors tend to be smaller objects, so when they come in contact with the Earth's atmosphere, they burn in the atmosphere. And if it happens, it's bigger or it's metallic, and you have a piece of that meteor that lands on ground, then we end up with what we call a meteorite. I think I had a good map. There you go. So when you think of, there we go. So when you think of asteroids, more and more probes, satellites, and telescopes are looking at what we call celestial objects in our solar system. So if you look here, it's a big mess. Are there a lot? Yes, there are. So often when we hear from the social media, oh, we've noticed that there is an asteroid that will be passing close to Earth, maybe between Earth and the moon, or closer to the moon, or twice the distance between Earth and the moon. The reason for that is that they are moving around. And often they're small, and therefore they could be but a bus-size object. But still, if you think of the vastness of our solar system, it's very hard to point out what they are. So we have here what we call comets. We have objects that are just there. Many of them can hit each other, bounce on each other. So what happens is you end up with these landing either on Mercury, Venus, Earth, and Mars. And we're lucky on Earth. We have an atmosphere that are protecting us from many of those smaller celestial objects. And if people are saying, well, it's scary because it could hit us. But if you think of the vastness of our solar system, to have a small rocks traveling on the path of Earth that is moving and actually hitting Earth, the percentage is very, very, very slim. So it may happen. It has happened in the past. And the question is, we can only aim at looking at them and see if there's a threat at some point to see what we can do. On this is the video I have for you on planets from our solar system, as well as celestial bodies in our solar system. If you've enjoyed this video, don't forget to subscribe to our channel. I'm always happy to bring new videos to our channel. If you have clarification questions or something you'd like to know more, put your questions in the comments. I'm always happy to listen, to read what you write, because it gives me ideas for new videos, or I can just answer the comments, because at this time, I'm always reading all the comments and answering all of them. On this, I'm going to wish you a wonderful day, and I'll put here a link to another video related to space, and you'll see we'll learn something more.